So in your little notes that you guys have, we're dealing with the Lewis structure. So remember that your Lewis structures are the things that have the little dots that go around it, okay? So when you're dealing with your Lewis structures, remember that we have atomic symbols that represent your elements. You have dot pairs or dashes that are going to show up between two atomic symbols. So we're going to start now bonding those things together. So we started with stuff where we had, like for instance, if we had oxygen, we knew to go 1, 2, 3, 4, 5, 6, right? So we had a Lewis dot diagram that we could draw to represent the valence electrons for everything on our periodic table, depending on what group they were in, right? Now what we're going to be doing is we're going to start bonding it together with something that can fill in right here, okay? So remember for our ionic stuff, we actually transferred in an electron. For covalent, we're going to actually be bonding stuff. So if I have another oxygen available, okay, you can kind of see that you get used to your drawings and then you start seeing that, oh, okay, so both of these guys needed two, so let's bond them together. And we're going to start seeing that. All right. Now, this is not the process that I'm going to have you guys use. I show you in the video how to use NAS, and I do require you to do that because it's not about connecting the dots. In the end, it'll look like you connect the dots, but I need you guys to understand fundamentally that it doesn't always look like dots connect, and there are lots of exceptions. So using NAS will help you with those exceptions, okay? All right, so dot pairs or dashes between them show the electron. So if you notice, a bond is representing two electrons. All right, in our final answer, we'll use a dash to represent the shared. Each dashed line represents two electrons. Okay, so dots are only attached to one atomic symbol, and they represent the unpaired. Dots that are only attached to one symbol represent the unpaired electrons. So over here, when we had these are your lone pairs. So the extra dots that aren't getting shared, they're not getting bonded, those are going to be called lone pairs. That's one of your questions today. The unshared pair is also known as a lone pair, not involved in bonding and only belongs to one atom. Okay, sorry to read that to you. This right here, this is an important image. Okay, you will see this one on the quiz today. So please note the different parts. So we have our chemical symbols. Okay, so what we've been using when we were writing the different chemical names and the formulas and crisscrossing charges and things like that, we have our chemical symbols right there. Then we had a line that goes across right here that was connecting those. So you guys kind of saw me connect dots with the two oxygens. That's what we're talking about. So anytime you have a line or a dash, we are showing the shared electron pair or the bond. Then you see that we have three lone pairs over here on chlorine. And if you remember, this is coming from chlorine being in group 17. Let me pick a different color. I'm sorry, y'all. I didn't know you guys couldn't see. 1, 2, 3, 4, 5, 6, 7. So when you guys were doing that, you were already making lone pairs. That's what those are called. Okay, so this is an important image. It says slide 5. I don't know if it's slide 5 or 6 for y'all. Okay. So just make sure you know that. The three parts. Okay. So you're also going to see in the video that there's going to be a couple times that it's more than one dash. So these next couple slides, which are in the notes that you guys have on your Schoology page, you're going to see a single bond is when you only have two electrons that are being shared. You can also have a double bond. So we see that between oxygens, you can share two things because there were two lone electrons that needed to be combined. Everything needs to have a pair, basically, all right? And so once you have this little covalent bond, you just took care of that. You are now saying, awesome, so this oxygen has all 8, and this oxygen has all 8. And that's what we're looking at here. Okay, so each of those lines represents 2. You can kind of see that being filled up right here. Okay, just like that. He has 8 electrons around him. Ultimately, that's what the goal is. Okay. And then you can also have a triple bond, which is so much fun. The one to remember for this one is going to be nitrogen. Always has that triple bond. Okay. All right. All right, so when you are going to determine your central atom, so I say this in the video, but I kind of leave out a couple of these details. You are looking for, I'm just going to go through these rules. So you have unique atoms, meaning there's only one atom of that element. So if I have something like NH3, N is unique. There's only one of them, okay? Okay. Often the least electronegative. So remember, on your periodic table, when we did your periodic trends, most electronegative was over here on this corner. Okay? So you want anything that's further away from here to be your central atom, with the exception of hydrogen, because number 4 says hydrogen will never, ever, 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 ever be central. Reason why? Hydrogen is in group 1, right? So if hydrogen is in group 1, he has 1 electron. Can he bond with anything else except for one thing? The answer is no. So because of that, hydrogen will never, ever, 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 ever be central, because he can't have bonds like that. That's just weird. Hydrogen only has 1 electron to bond. All right? Okay. Carbon, if you have carbon as an option, put him in the center. Carbon is a very friendly element. So usually when I get asked what's my favorite element, I like to say carbon a lot, because I'm like, it's so friendly. It's a happy little element. I don't know if it's my favorite though, but anyway. All right. And then check for octets and things like that. All right. So I would say these main 4 things, usually use those. Okay. And so when you go to do your own, make sure you remember those 4 rules for who goes in the center. Okay. The next slide kind of shows you how things are bonding. So this is going to be the part where I'm going to actually switch over, and I'm going to go to the NAS thing, which you have a whole video over. So please, if this goes too fast or you don't understand where I'm going with this, you need to sit through that video and you need to take your notes, okay? So if you'd rather just go straight to that, I understand, that's fine. Just make sure you do your check-in tomorrow. All right, but with N minus A, because you're going to have to fill this out on your quiz today, equals S. And this is how you're going to list them out. N is going to be needed, okay? So N is needed. So your answers for needed is always going to be 8, unless you are hydrogen. If you are hydrogen, hydrogen needs 2. If you are beryllium, beryllium needs 4, and boron needs 6. But all the time, you're going to be talking about 8. So when I have something like NH3, you have to list out what each of these elements need. So I would, if I were you, while you're starting out, list out what these elements are. So I have nitrogen, I have hydrogen, 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 just like that. You're going to be adding together what all of these need in order to have their full octet. So nitrogen needs 8. He's one of the usuals, right? So we're going to go 8 for nitrogen. For hydrogen, hydrogen is one of our special ones. That only needs 2. This hydrogen only needs 2. This hydrogen only needs 2. Once you have that, let me see if I can shrink this whole thing. I'm going to push that off. All right. Once you have that, you're now going to add those together. So we have 8 plus 2 plus 2 plus 2. So 8 plus 6 is 14. We've done our N. Okay. So the next step is going to be available. Okay. So available. For available, that is your valence electrons. Okay. Valence electrons. So nitrogen, pull up your periodic table. Nitrogen is in group 15. He is 15. Okay. That means 5 valence electrons. You have to pull up your periodic table. If you have no idea what I'm talking about right now, you need to remember to pull up that periodic table. And actually, just to stress it, I'm going to pull up that periodic table so that way you guys have it. There it is. All right. So in my periodic table, nitrogen is right here. right? He's in group 15, which means he has 5 valence electrons. So once we've decided that, we know that we're going to put a 5 right here. We got to add it to what hydrogen has. So hydrogen is over here in group 1. That means he has 1 valence electron. So we're going to move that back down. We're going to say plus 1, plus 1, plus 1. So I have 5 plus 3, which is going to be 8. Okay. Now we're doing subtraction. Okay. So nothing goes here. We're taking these two numbers and we're going to subtract the 2. So 14 minus 8 gives me 6. That means that I have 6 shared electrons. Okay? So how many bonds does that equal? How many electrons were in each bond? 2. That's a question today, by the way, on your little exit ticket. 2 per bond. So we're going to say, since there are 6 that get shared, according to this math, if I divide it by 2, that tells me that I have 3 bonds. Okay, so once you've done this, so I am asking you on your quiz today to run through those steps. Once you've gotten through the math part, now you go and draw it. So notice, no connecting the dots. You are basically saying, okay, now according to those rules, I know that nitrogen is the unique one, right? So once again, this is the compound that we're dealing with. Nitrogen is all by itself. It's the one that's weirdo. It's the standout. It's also the least electronegative out of the 2. And the hydrogen can never go in the center. So we're going to write nitrogen, and then we're just going to put these little hydrogens all around it. Okay? Okay. You have 3 bonds. So we're going to go 1, 2, 3. Your last step is to go back to your available. We had 8. Each of these bonds counted as 2. So 1, 2, 3, 4, 5, 6. You have to put, so if you notice, hydrogen has 2, he's good. Hydrogen has 2, he's good. Hydrogen has 2, he's good. Nitrogen only has 6. How many did nitrogen need in order to be full? 8. So we're going to add those last 2 to nitrogen. And now you're done with your drawing. Okay? So take your time, write notes from the video, take notes over the examples that I show you in there. We will be picking it up again after Thanksgiving break. Okay, so just in case you don't get it the first time around, and on this quiz, I made it to where you have 1 try, but it shows you the answers so that you can see how to fix it by the time we come back. And so do your best on it. Let's see how far we get. And then tomorrow, I'll kind of look through to see how people did today. I know it's not going to be everyone, but I will check to see what people did today. And that way we have something to work with tomorrow. And I can address things that you might need help with. Okay? All right. So that's what you're dealing with there. Okay? There's a lot. So please go through the notes. Try it out. Try out the little math. Try the little drawing. I think in your actual exit ticket, I put the letters already for you, so you don't have to do as much thinking with the how many bonds to draw. But there's still, I think, one that shows up as a double. So be ready for that one. Okay? All right. Other than that, once you get through that, I give you a chance that you can try out a couple on your own. You do not need to submit anything back. It is meant for you to try some on your own. And then if you would like the answers, email me and I can check your work or I can send you them. Otherwise, we'll go over the answers tomorrow. Okay? All right. And then you have a little exit ticket and you are done. All right? So please double check your grades. These next 2 days are meant to do this and your makeup work. All right? So get yourself in a good spot. Make sure you come back tomorrow to at least check in for attendance. And then, yeah, that's it. All right. So I'll leave the Zoom call open in case you guys need anything. And then we will deal with that. Okay. Go knock out your assignment. Good job.